Hello, my name is Sabrina Schembri. Welcome back to my channel, or welcome to my channel if you're new. Today, I'm going to be discussing dead loads. So, first off, what are loads? Well, loads are essentially any forces on a building, and these forces can affect a building in several ways, some of these ways being negative. For example, one type of load is a lateral load, and an example of a lateral load is a wind load, and wind loads can cause horizontal displacement in a building that isn't braced properly, and horizontal displacement can later lead to structural failure, which is not good. But today I'm going to be discussing dead loads. So what are dead loads then? In short, they are the permanent loads on a building that do not change over time and cannot be removed. So, for example, the weight of the structure of a building is considered a dead load. You can actually solve for the dead load of a component by multiplying the volume of the component by the density of the material that it's made of. So, since this type of information is pretty easy to find, usually dead loads are the most accurate loads to actually estimate. So the dead load includes the load of the component itself plus the load of whatever it's supporting. So when you're considering something like a column, you're going to want to add the dead load of the column itself and the dead load of the beams and the slab that are resting on it. And the same goes for a beam. When you're calculating the dead load of a beam, you calculate the beam itself and the dead load of the slab that it's supporting. Slabs are a little different. If the slab isn't supporting anything, then you would just calculate the dead load of the slab itself. But if it's supporting any floor finishing or any fixtures, plumbing, electrical pipes, etc., then all of those things need to be considered in the overall load, the overall dead load. So the dead load on a building also depends on different factors, including the types of materials used and the presence or absence of things like permanent non-structural elements. Again, like I said, pipes, this includes like roofing, partition walls, and different things like that. So as I mentioned previously, you calculate the dead load using the volume of the component, which is whatever you're calculating the dead load of, and the density of the material that it's made of. So since different materials obviously have different densities, this affects the overall dead load calculation. So for example, cast iron has a density of about 450 pounds per cubic foot, whereas reinforced concrete's density is about 150 pounds per cubic foot, and the density of oak is about 47 pounds per cubic foot. So, dead loads, as all loads do, travel from the top of the building through the structure, and they are transferred to the supporting soil. The load path of a dead load goes down, while the footings or whatever foundation system there is counteracts those forces and goes up. So I prepared a little illustration of the load path for dead loads and also the load path for live loads, and I'm just going to be showing you that so you can compare. So first off, here is the load path for the dead load. So I outlined the building in pink, and the arrows in green are the dead load. So the ones on the outside are accounting for the weight of the structure itself, while the ones on the inside are like the plumbing, the electrical pipes, the fixtures, etc. And the arrows in red are the foundation counteracting these forces. And just to compare, here is the load path for live loads. It's a little smaller, but I showed the lateral loads, like the wind loads, acting on the building, as well as these arrows and the smaller arrows to represent things like snow or rain loads, which are live loads, and people walking are also live loads, and furniture, things that can be moved, and things that aren't permanent are live loads. And again, there are the same arrows to show the counteraction of those forces from the footings or the foundation. So I just wanted to show both so that it didn't look like I was just drawing random arrows, but this is the path of a dead load versus the path of a live load. It's a little different. Both have arrows going down, and this is also due to gravity. So I just wanted to mention also that the gravity load also includes the dead load. Basically what the gravity load is it's the total dead load and the live load combined. So that's why you can see arrows going down. Gravity is a force that goes down. So in summary, I explained what dead loads are, and I showed you the load path for dead loads. I also explained how to calculate dead load. Just to remind you, that is by taking the volume of the component and multiplying it by the density of the material that it is made of. And again, dead loads are the permanent loads on a building, and these can come from the structure of the building itself, as well as from the other components, like the fixtures and any permanent non-structural components of the building. So that is all I have for you today, and thank you for watching.